Hey everyone, you're here with Mark Bowell at Perfect Gardens TV. So today I just want to say congratulations to Coherence for winning the 2-ounce drops of balance. He ended up correctly identifying the problem with the recent pictures I was posting. And in this video, we're going to get into nitrogen, phosphorus, and potassium toxicities and breaking them down step by step. If you guys haven't checked out our monthly membership, for only $2.99, you get direct access to our private membership group. So far, we have over 839 pictures, 126 videos, 7 files, 13 audio files, and a whole bunch more knowledge that we're constantly covering on a daily basis. Make sure to hit the join button on the bottom of every video. Okay, before we get started, please remember to like, share, and subscribe. It super helps with the YouTube algorithm. It's also helpful to put a comment down below. Thank you guys. Alright, also, right down below in the description, I normally put the Google links to this presentation, so make sure to take a look and follow along. If the link is not there, please put it in the comments below, and I'll make sure to include it. With this post getting over 200 comments and over 160 likes, this is definitely something I want to cover with you guys, because with over 200 comments, there wasn't a lot of people that came very close. And I'm not trying to knock anyone down, but what that tells me is that I really want to do a thorough job explaining these toxicities so that you can identify them later on throughout your own grow. Once again, guys, I really appreciate you guys posting those comments down below. Some people get upset that I take a couple days or a week or even 2 weeks to reply back to those. And it's mainly because I want people to just think about it, post their comment, I'm going to come back to it, and through that process, I'll normally be doing a nice thorough video for you guys. Okay, so the first one. In this picture, just like how Coherence said, nitrogen toxicity, there's dark green leaves. And I wanted to show you this, right? This is, and just like in that PowerPoint presentation I provided in the Mr. Grow Up video, right here at the top, you'll see excess and deficiency. When you come down to the bottom, you'll see one of these being one of the main signs for a nitrogen toxicity is bottom leaves turn lush dark green. So as you can see right here, there's this lush dark green happening on these lower leaves, and as you travel up, it begins to lighten up. That being said, these are one of these key signs of how to identify if you're running through a nitrogen toxicity. Other ones could include the stem becoming weak, foliage becomes weak. And again, why is it becoming weak, right? The nitrogen, we're going to cover this in a few minutes. The nitrogen is for amino acids, right? That's important for stem and leaf development. The plant is growing really quickly. It doesn't have the other minerals it needs, like calcium, for example, to be strong. So that's why when it's growing quickly, that's why you'll have weak stems, because again, it doesn't have the other trace minerals needed when it's quickly going through cell division as it's creating new growth. And obviously, last but not least, your end product might taste a little green. Next picture is a phosphorus excess. New leaves grow thin bladed. So as you can see right here, this is the top leaf and it's thin bladed, but the bottom leaf right here is pretty wide. So this is a really great example of a phosphorus toxicity. New leaves develop interveinal crosses. So as you can see right here, the crosses is happening. It's very easy to mistake these things as a calcium deficiency or a zinc or a magnesium deficiency, because the crosses is happening right where the magnesium deficiency would happen. And as you can see right here, the yellowing on the outside of these leaves, that also is an indication of a zinc toxicity. But remember, the law of minimum and the law of tolerance always comes into play, and you'll be able to see it in the plant in one way or another through your general observations on a daily basis. Remember, make sure to stay to the end, because I'm actually going to break down the nutrient line that this gentleman's using, as well as a little bit of geeky stuff. Last but not least is the potassium excess, right? So new leaves grow thin bladed. Once again, new leaves are growing thin bladed, as you can see all over this plant. New leaves develop interveinal crosses. And I know what you're thinking, right? Like, you just said this on the phosphorus. Yes, well, phosphorus and potassium actually have a close relationship. So some of their toxicities and deficiencies will actually show up in the plant very similarly. Some things that are clear signs of it, though, is less internodal spacing. As you can see, this plant is super stacked on itself. Whenever I see that as a characteristic on the plant, I'm always taking into consideration, is it a characteristic of the phenotype, or am I dealing with the nutrient toxicity? Once again, as well, causes calcium, magnesium, zinc, iron deficiencies. So we're having a primary toxicity, but it's showing up as a deficiency because it's locking out the other minerals. So let's go ahead and get into geeky stuff. Nitrogen. Nitrogen is an amino acid, right? So it's used for stem development and leaf development. So whenever the plant is growing, it's going to be using calcium. When it stops growing, it's going to be using less calcium. This is important to understand because when you're using synthetic fertilizer and they're dumping on the urea or other types of nitrogen, the plants will actually grow really quickly. And if the plants don't have the other macro or trace minerals needed while they're growing quickly, deficiencies, toxicities, bug problems, mold problems will start normally. If you haven't checked out my video on the benefits of nitrogen, please go ahead and do so. I won't get into it on this video, but nitrogen does play an important role all the way through, even through the curing process. Benefits of phosphorus. Phosphorus collects the sun and carbon dioxide to produce ATP. That's why they call it adenosine triphosphate. So in a sense, the plant's producing the sugar, in a sense, as an adenosine, but then it combines with 3 phosphate groups to produce ATP. I think personally this is also where a lot of people mistake when they say or encourage people to be feeding their microbes with sugars, right? Because technically the microbes aren't eating sugars, they're eating organic compounds. And the sugar technically actually had already combined with other minerals to create those organic compounds. And I think I'm saying this properly. That's why I'm always rethinking the whole sugar process. And I look forward to getting into that whole subject in later videos. Plants release the O2 and store energy in the form of sugar or glucose in the root system, which later combines with amino acids to become aka exudates. And this is what I was talking about, right? So the plant's producing the sugars, but these sugars are later combining with other amino acids to create different forms of exudates, which basically tell the bacteria and fungi to go produce specific trace minerals and to go and retrieve them and collect them. Last but not least is the benefits of potassium, potash. Aids in photosynthesis and food formation, helps convert sugars into starches, and stores in the root system for long-term storage. Increases root growth and improves drought tolerance by building cellulose and reducing weak stems. Maintains turgor pressure, so it basically helps the water stay within the plant so that if the plant isn't perspirating crazy and it's actually retaining its water, it's going to be going through less mold problems later down the road, and you most likely are going to be running into less botrytis. So as you can see, potassium definitely is beneficial. I always talk about drops of balance and the law of minimum, the law of tolerance. Just increasing your trace minerals more often than not can save you from having a toxicity, right? Because if you boost up these trace minerals, the macro minerals will have a different threshold of tolerance. So at the end of the day, I'm always pushing drops of balance for these reasons, whether you're a synthetic grower or you're a beneficial bacteria living soil grower. And also the law of tolerance. We've already talked about this many times. If it goes out of these optimum ranges, less of minerals will become available. Same thing like temperature. If it gets too hot, and I've showed you this in other videos, you can actually run into a deficiency problem, even though there's more than enough nutrients in the soil. And once again, I always love to show this because you could see all of these minerals are playing a part together. Okay, so this grower right here is using the Floraflex, and as you can see right here, that this nutrient line uses urea, and these, whenever you see the red right here, these are nitrogens I highly recommend not to use. Why? Because they fall outside of the natural nitrogen cycle, and I've talked about this in the other video about the benefits of nitrogen, so make sure to check out that video if you're interested in learning more about that. But as you can see here, it makes a lot of sense that they might be running into a nitrogen toxicity, right? Especially if they're using fertilizers that are meant to just mainstream the plant with nutes. Same thing, because they have a veg 1, veg 2, and it's a 1404 and a 61725, it's real easy that if you overdo it or have a dryback period, more often than not, you're going to run into a toxicity. And as you can see, it makes sense that this problem is occurring with this grower, because I want to say because he's using this line, it's just because he might be using it with tap water. He might have overfed a couple times, and before you know it, ends up adding up. Also, as you can see, the foliar feed is a 3910. So they're just nuking the shit out of this plant. Anyways, I hope this video was helpful on understanding and interpreting nitrogen, phosphorus, and potassium toxicity. Please remember to give me a thumbs up, like, share, and subscribe. Have a great grow, everyone. nature actually has a fast release and a slow release fertilizer program. I know that might sound kind of crazy. The fast release comes in the relationship of lightning storms, and when a lightning bolt actually discharges, the lightning will split nitrogen bonds